Adrian? Good. Okay. Well, hello everybody. Glad that you guys made it. I know it's one of the last presentations of the night, so I really do appreciate all of you coming here. So the presentation is on DNS Reconnaissance. It was supposed to be on the Teach Me track, but somehow I got into the Break Me track, so let's see how it goes. For those of you who do not know me, my name is Carlos Perez. During my day job, I work as the Director of Reverse Engineering for a security vendor. I'm also one of the podcasters in the Paul.com Security Weekly podcast. In addition to that, I'm one of the contributors to the Metasploit framework. Many of you probably will find my work under my handle, Dark Operator, in Metasploit. I have a blog called www.darkoperator.com, and my Twitter is at Carlos_Perez, not at Dark Operator. That's another guy. And yes, he also speaks Spanish, and he is also into security somehow. And he doesn't want to give me his handle. No. He said he got, in a matter of 1 month, 2,000 followers all of a sudden. I said, okay, I'll keep it. Disclaimer, all of the research that I'm going to show, which is not much since it's DNS, almost everybody knows DNS, but everything that I'm going to show is on my head. My current work does not, my day job is not in any way related to it, and my CYA, they're not responsible for anything I say, and they do not condone any of my actions. So, yeah, now you're getting the idea of some of the stuff I'm going to be showing. So what is Recon? One of these important things for me is a systematic and methodical approach at gathering information about the targets, networks that we want to pen test. And I want to put an emphasis on systematic and methodical. Even though I do a lot of code automating stuff, there are times when I find that automating too much is bad, or automating everything is bad. We are the humans, we're supposed to kind of control the software, we're kind of to be responsible of what we're doing. And for those of you who know me a bit better, know that I tend to be kind of a tactical person. I come from a military family, I come from a tactical background, I used to train people on how to put holes in two-legged animals, and I come with a different type of mentality when I'm approaching stuff. I like gathering detailed information of what I'm doing, I like planning ahead of time, I like knowing how am I going to approach a problem, and how am I going, and what are the best techniques for me to do it. So that's why I put kind of emphasis on systematic and methodical. The information we gather will actually give us an idea on the security posture of our target. Just by gathering information from it, we're going to be able to determine or measure the level of skill of our defender at the other side many times. And many times not even the security guy's fault. It's the admin administrating that that's not listening to their security guy. So there we can kind of enumerate their communication also. So why DNS? Why do I focus a lot on DNS, and why did I build a tool for enumerating DNS? Right now, if you're a Windows administrator, one of the things that you're going to notice is without DNS, your Active Directory does not function. Without DNS, Exchange doesn't function. Without DNS, you're having problems with SharePoint. Without DNS, your link implementation doesn't work. If you're a Cisco person and you decided to kind of hack it and go with static IPs for everything, that works very well on small environments, but when you start doing VoIP with integrating with instant messaging and other stuff, you need DNS. You need those SRV records. You need those entries so your VoIP system can work. Many of the management systems, when we're implementing those, we need DNS so we know to what IP are we connecting to, and we need that naming scheme. So DNS becomes very important and critical to many infrastructures nowadays. So why don't we kind of exploit it and reap the benefits of it being so open? So for the, but One of the things that I have noticed is that a lot of the organizations that I have worked where I was on the attack side and others that I have helped on the defense side is that nobody logs DNS requests. Nobody is actually looking at their DNS traffic, or at least not a lot of people do it. So when I'm looking at all of that stuff, I'm noticing, how many times do you know that failures are happening in the queries of your DNS servers? Oh, we don't log that. Did you actually log if somebody actually tries to do a zone transfer? Oh, we used to do it, we do not any longer. And then I start finding that some security teams actually kind of ignore those admins and they do enable that into their IDS, and the only rule that they actually have is, did somebody try a zone transfer against one of my servers? That's the only thing that they're actually monitoring from their DNS servers. Some very advanced clients, and I can count those with my left hand, and I have fingers missing from my left hand, actually only monitor or look at TXT records because they know that's one of the known techniques for people of exfiltrating data out of a network, and that's the only thing they actually look at. And then that, nobody's looking at it, so we can kind of abuse it. So one of the caveats that attackers we do have when we're working with DNS is that DNS is UDP. So we're very dependent on location, location, location. We have to be close to our target. Because if we have a lot of delay to our target, stuff stops working. Let's say when Bob started testing some of my tools for me against certain countries or certain IP ranges, one of the things that Bob gave me as feedback was that he had to buy several VPS systems in different places to actually get the proper data out of those systems. So location becomes very important because many times DNS will respond to one IP address that is closer, we have less delay in a certain way and provide certain records that it won't if you're in another IP address. So location tends to be quite important on that side. Another problem is that DNS many times tends to have stale entries, wrong entries, and as a couple of friends of mine actually do, they create their own kind of honeypots on DNS. They set fake records pointing to the FBI, fake records pointing to the NSA, fake records actually pointing to systems that they have an IPS actually monitoring all of that traffic and capturing, just waiting for somebody to actually see those records from that fake zone transfer for that special last DNS server in the list of NS records, so they can catch the attacker on it and can kind of funnel all of the actions from that attacker into systems that will actually not impact their environment. I have actually seen that happen. I found it quite interesting. So for this, I built a tool about 3 years ago. I had a tool called DNS Recon written in Ruby. The Ruby library I was using was not that good. Had a bunch of errors and problems. I started multi-threading, and I kind of changed it to Python. I did a port for Python, and then last year I started kind of migrating that code into Python 3.x. So right now, the state of the tool, you can either run it in Python 2.6, 2.7, or 3. For Python. I added several features. One of those is that I wanted that output to be in a usable form. I want to be able to parse that information because many times we're going to get a lot of records. We're going to get a lot of information that we need to sift through it and find the gems or the real information there, because many times that information is going to be useless because there are going to be a lot of stale records. We're going to find a lot of old records that do not have a record associated to it. And we're going to, or probably we're going to hit a target that actually has thousands and thousands of records. So to do that, I set up different exports or different ways of saving that data. So it will save into XML, CSV, or into a SQL-like database. So that way you can choose your own poison there, and you can choose what is the best method for you to actually parse that data. Not only that, but I also included in the tool last year Metasploit plugin, so you can actually import the XML or CSV data into Metasploit, and it will match the services for the SRB records. It will match the services depending for MX records. I'll add the port 25. For NS records, I'll add port 53, and for other known ones, I'll add the proper port for that service if I'm able to verify it. In addition to that, I even wrote a parser tool, so it's easy for you to kind of parse that tool. I kind of wrote the tool initially for myself, and then I started using that. I gave that tool, put it in GitHub. A lot of people started using it. The guys at Accuvon started using it a lot, started sending me a bunch of feedback. Random Storm from England started using it a lot, sending me feedback. And DigiNinja has been kind of, Robin Wood has been kind of the biggest user of the tool, always asking me for new features, always sending me some weird bug that happens with only one specific client that decided to only have one single NS record, no SOA, and no MX record, no other settings, or one weird DNS server that responds to packet in a different way. And I have improved that tool a lot thanks to him. So the current build that I'm going to push tomorrow to my GitHub is going to be called the DigiNinja Edition, just as a thank you for him, because the guy has really helped me polish that tool, sending me some of the weirdest scenarios that I never saw, hitting several targets in the US, China, and Russia, and go like, dude, what's wrong in England that you're seeing those? So he really helped me there. So I'll do this as a thank you. One of the goals was to provide most of the known methods for enumerating through DNS. I included those in the tool. One of the things is I wanted to control all of the different actions for enumerating. I do not want it to actually go get all of the whois records for all of the IPs and start just going at them willy-nilly on its own without me controlling which one it will actually do it. I want it to actually ask me and me choosing. Why? A lot of people are moving to cloud. Don't know why. They're giving their control over to somebody else who they do not know who they are or what they're doing with those servers and what controls they have. But people are actually using cloud more and more, and they're giving that control away. And many times I probably do a whois accidentally with any other tool. It will give me an IP range. I start hitting that IP range and I'm hitting somebody else, or I'm hitting another company completely differently. And from the legal standpoint, that's bad. In addition to that, I want to control zone transfers because I know that's the only thing that somebody's actually looking at. And I don't want my tool to find a zone transfer and exit. I want it to keep it querying all of the different NS servers and getting me other records so I can compare, is that zone transfer really valid, or is somebody setting a trap for me? Or is somebody playing coy with me? Because I have seen it actually happen in the wild. So the types of enumeration that I added to the tool was one that is called standard enumeration. It will actually check for wildcard records. This is very important when we're doing brute forcing. It will actually tell me if you have, you're resolving for wildcards. So if I try to do a brute force, everything will turn up at 8 record for a specific IP. So I want to know if that's there so I know if I'm going to waste time doing it or not. In addition, I'll check if you're using DNSSEC. And if you're using DNSSEC, am I using NSEC or NSEC3 when I'm doing it? Because later on you will see that I can perform zone walks. And I can actually get kind of a zone transfer out of DNSSEC if you're using the wrong settings on it. In addition to that, I can get NS, SOA, MX records, A, Quad A, TXE, SPF, and SRB records just from the standard enumeration. And one of my favorites is SRB records. Zone transfer, reverse lookup of an entire range. I can do a domain and host brute force, cache snooping so I can know what domains are you actually checking and connecting to, so I can check if I'm going to do a phishing attack from any of those domains that you already are accessing and you actually trust. Zone walking against DNSSEC, and I added Google lookup so I can enumerate through Google also a couple of the subdomains. So when standard enumeration, as I mentioned, I check for wildcard records, DNSSEC type, so I can abuse the proof of non-existent record. I will resolve the certified authority, name servers, mail servers, A, Quad A, TXT, SPF, and enumerate several of the SRB records, well-known SRB records. And one of the important things that I've noticed is I check for dicking which is domain key identifier mail and sender policy framework records. Because if I see both of those in a domain that I'm enumerating, that means that those people are taking spam very seriously. And many times they'll even go and set policies on their clients to actually validate which domain is doing that. So I'll take that into consideration when I'm doing my phishing campaign against that target. This is already giving me an idea of what to expect from my target when I start going in. This is just giving me an idea of how ready they are, how much time they spend on planning, depending just by looking at those specific records, how did they set those up. So I'm able to read my opponent when I do that. In addition, SPF records actually tell me which servers or which IP address can actually send email to the outside world. This means that those servers, I can actually push my shell back to me through port 25. So I'm getting an idea already on data exfiltration just by looking at those standard records from my target. SRB records, they're a gold mine. You're telling me the port, you're telling me the server, you're telling me the protocol, if it's TCP, UDP, if you're using TLS or not using TLS, and you're telling me which server is more important than any other, and how are you offloading the load through all of those servers. So SRB records, you're just giving me everything. You're giving me all of the information I want. So they're on themselves a gold mine of information. In addition to that, I'm going to get the standard 8, quad A, and CNAME records. In addition, one of the things I added to the tool is if I'm able to know that there's a host name with that name, but there's no associated A or quad A record, I'll flag that as a no underscore IP in the tool. That will actually tell me if you're maintaining your actual DNS infrastructure or not. Are you testing it? In addition to that, it might lead me to look at possible DNS record leakage, that you're actually leaking DNS records from your internal network to the outside world. And I have examples of that. So to run standard enumeration is just DNS recon minus D, the domain, or DNS recon minus D, the domain, and minus T for type standard. I can modify the way it executes. As I said, I like having control over my tool, not my tool having control over me. So I can give it a minus A. If I give it a minus A, it will actually check if port 53 TCP is open on any of those NS records. And if they are, I'll try to do a zone transfer. If I give it a minus S, it will go into the SPF record. It will take all of those ranges in the SPF record, and I'll do a reverse lookup against them. Because you gave me the data. So if you gave me the data, that means that's public and you want me to actually do that, I guess. So here we have an example of Cisco. So I set DNS recon minus D Cisco. I get the standard records from them. Then I get that big record over there, a TXT record with the FPF. And there you're going to see several /14, /16s, /24s. Those are very large ranges. So I want the control if I actually want to reverse look up all of those ranges. In addition to that, I'm getting SRB records. I already know that they're using VoIP, which is they're using SIP over TCP, secure SIP. I already know the ports for it, 5060, 5061. I know they're using H323. I'm also seeing that they're using Jabber. I see that they have SIP Federation TLS, so that means that they're using Microsoft Link. And they're connecting to other systems, so I already gather information from them. I know you're using Jabber. I know you're using VoIP. I know you're using Exchange and Link only by looking at the DNS records. And I know that you have a ton of IP address space that can go out through port 25, and a ton of address space that I gotta decide if I'm gonna put time into actually reverse looking up all of that space. If I actually did it, I did the SPF expansion. I set up at 9 a.m. I think around 10 p.m. it finished. And then when I changed to a VPS provider somewhere closer to that address range, it actually took like 4 or 5 hours. It took even less because I had bigger pipes to actually query the data. So location, location, location. So we look at zone transfer. I am still finding this a lot, believe it or not. So, hello, 1980s, 1990s. They're still there. The way the tool will work is I'll find the start of authority, I'll set my resolver to it, and then I'll query for all of the NS records and then try each one of those. Then I'll parse all of those records and I'll check each one of those records if they're valid, and I'll try to even resolve some of those manually to see what are the IP ranges that I'm actually getting, or if I'm getting extra A, quad A, or CNAME records out of those. So I'm actually doing a lot of checking in the background against each one of those records to provide you that info and formatting it in a way that's actually useful for the pen tester. I'm not just dumping that text that I get from that zone transfer. In addition to that, I like to kind of control when it happens, because that's the only thing that most IDSs tend to look for when people are actually not using them in the learning mode most of the time. Even when the zone transfer is successful, I like querying the other servers that are there. That way, when I query all of those other servers, I can know if there are differences in the record. Am I being played, or are they just not maintained or not? To do some transfer, I just give it -A or type AXFR, or if I want to mix standard with some transfer, I can just, in the type, I can chain different types together when I'm running the tool. Reverse lookup, all of us already know this. We just go from IP to name, and in my case, I'm just getting IPv4 to IPv6. In addition to that, I gave it the option of expanding SPF records so we can actually get those and we don't have to kind of determine those. One of the things I actually did is I added whois query. So a whois query would be that all of the records I'm getting from the standard enumeration, I'll grab each one of those IPs, I'll multi-thread 10 instances at the same time via UDP, query those depending on the range and what whois server should use. I use a library from Ruby called netaddr, which is great because if I give it an IP, it will actually tell me what whois server I'm supposed to actually use for it. It has an internal database for it that gets updated regularly. So I really like that library because then I start doing specific queries to these specific whois servers that I should be querying for, getting all of that data at the end, and then I'm parsing it for ranges and name of the organization for it. So I know that if I'm kind of targeting one specific organization, I don't target any other. Let's say if they're using Google Mail, or if they're using any other company or hosting provider, I make sure that I only target them and not the other person. So the way I do it, I can give it a sitter, I can give it a start or NIP. For SPF, I just give -S. For whois, I give it a -W to do it. And I can chain all of these options. I'm just showing them right now for simplicity. So the way it will look is like this. I can give it a range, and there you can see it running through a range of my lab at home. There you're going to see my firewall, my 3ESX servers that I have in my lab at home. Yes, I do run 3ESX servers as my home lab. And then here I decided to test Hewlett Packard because Hewlett Packard really has some big ranges. And they actually use Akamai and other service providers. And I did the standard enumeration against them. And here you can see the whois results where I'm actually asking you, which one of these ranges that belongs to this organization do you want to scan? And are you sure you want to scan them? In the case that you probably run any other tool that actually does this automatically, can you imagine scanning 2 Class Bs? How long that would be? And in addition to that, that one that is not found is an actual third party that owns that range. So if I would have done that in an automated way, I'm probably hitting a company that I'm not supposed to. I'm going to be getting a lot of trash and records that I cannot use unless my rules of engagement actually tell me I can go after them. Domain brute force is the typical one. For each one of the entries in a dictionary, I'll actually check for A, quad A, and CNAME records. Just give it the domain, a dictionary, and a type of brute force. It will perform first wildcard, and it will actually tell you wildcard is enabled on this domain, and wildcard's resolving to this IP address. That's going to be useful if you actually find it, if you want to use the parser tool to filter that IP address out and find the real records from that. That's why I'm exporting to CSV, I'm exporting to SQLite, I'm exporting as XML. So that data, you have 3 different types of data that you can parse whichever you actually feel the most comfortable with. So here we have an example of a brute force against Google, and you can see it running. I'm getting A records, CNAME records, quad A records, just simple DNS stuff. Cache snooping, this one I found to be very useful for phishing campaigns, because I'm going to start checking for domains that actually do not have SPF or DKIM records that you are actually trusting. So I'll create a list of known, very popular domains that actually do not enforce that type of protection for emails, and I'll check if you're actually connected to any of those in any recent time. I'm checking your cache in your server to see if you actually have resolved that. If you have, that means I can do a phishing campaign mimicking that other company, and my success rate will be semi-high because you're not blocking those. You're not checking if they were really sent by that other target. I'm using this info to kind of determine what are my next actions, where am I going to attack, and how am I going to do it. So as you can see, we can read a lot from a company and how they do stuff just by looking at DNS. Here we have an example. This is against my own at home, and you can see that I started resolving a bunch of for google.com in this case. I had another example, but I was asked to remove it for legal reasons, so I removed that one. Sorry for that. For NSEC zone walks, this is kind of fun. I find a lot of companies that have actually been saying, oh, we've moved to DNSSEC, we're safe. Yes, you can trust us, and you can see it in your marketing material. Yes, we're safe, we moved to DNSSEC. Well, there's this flaw that was found in 2005, or mentioned in the RFC in 2005 that says, well, NSEC has a problem. NSEC is the proof of non-existent record, where an attacker can actually enumerate an entire zone depending on the way he queries each one of the records for that zone. It's a bit slow, but it's accurate. And I found it to actually rebuild internal records for some companies that actually have in one single name server. They kind of decided to use it for internal and external. I'm able to enumerate their internal zone also when I have done this. And the problem is that detecting this is hard because it's an actual feature of the protocol itself, of the DNS server. So it's hard to actually block it. I did find out that one of the domains that I was using during testing, they found out I was doing this. And we started kind of a cat and mouse game where they start implementing different ways of blocking zone walks. And then I had to work for a week or two finding a way to bypass that countermeasure. And then they came up with another one. I spent a week or two trying to find a countermeasure, finally got it, and a week before this presentation, they implemented one that really threw me off. I was banging my head. I even had to talk with one of my friends at work, Matt Kalawaji. He's a great Python programmer, and he looked at my function and says, dude, this is spaghetti code. All of the code that you have is so beautiful, but this one, were you duct taping this code? I said, yeah. It was a cat and mouse game, so I started adding stuff, adding ifs, it checks here, checks over there, checks over here, and he kind of helped me rewrite it, and we tested it, and we have been able to bypass all of the 3 different defenses that target was actually implementing. So I'm really happy with that function itself. I'm not going to show that target. I gain a lot of respect from them, so I'm not going to show them in my example, but I'm going to show some others that do not merit that. So in the case of NSEC, the way it works is when I request a record, I get back my response. If I request my record misspelled, it will actually return me that the record does not exist, but in the authoritative section of the payload that I'm getting back, it's actually telling me By the way, the next record in the zone with a similar name is this one. Was this the one you were looking for? So I just start kind of abusing that, and I start appending at zero, appending random text, appending hyphens and other stuff to get different responses until I get the one I want. And I know that I ended because the last record that I'm going to get from a zone walk is the top record again. So I start, let's say, with Comcast.com. So the last record I'll get is Comcast.com. So I know I finished that. But the standards committee came up with NSEC3. Now those values are hashed. They will actually tell you we're hashing this with SHA-1, and it goes through a process for you to determine those. You can still do it, but it's very computational intensive, and it takes a very long time. You get one record, 5 minutes later you find the other one, 10 minutes to 5 minutes you get the other one, and depending on the size of your chart, it's just not practical when you're talking about NSEC3. So here's an example of Comcast.com, where I started getting a bunch of records. In fact, I got thousands and thousands and thousands of records. And that's not the bad part. Now we can start talking about leakage. I did SRB leakage, and all of a sudden I did this with Dell. In fact, I reported to Dell 9 months or 10 months ago. So I was looking through their stuff, and all of a sudden I was looking through their SRB records, and I was looking at it and I was like, whoa, Kerberos TCP. Huh, that looks interesting. Then I kept looking at it, and then I started seeing KPass WD. Huh, LDAP. Interesting. Oh, those names look internal. And then I started seeing several no IP. I go, this is strange. And I know that several of these servers are actually DNS servers, so I started testing some at random. I wasn't going to port scan, I just decided to start choosing one after the other until I hit one DNS server, see if the firewall was misconfigured or something, and I did. One of them actually started giving me IP addresses on the 10 dot range. So those are actually internal records, internal IP addresses. And I did only an SRB lookup, and I enumerated 705 of their domain controllers on the inside through SRB. So that's a lot of data. And we're like, what would happen if I... So I went and said, what would happen if I do a reverse lookup against that class B? It worked. And I'm only showing a small sample here, but when you start seeing receptionist, O1, access point, HSRP, core switch, and names like those, you start going like, interesting. And then when I checked the zone transfer for Comcast, I started seeing these IP addresses. 172.30, those are not internet routable. When I was checking the DNS zone walk. And then I look at the name, ILO. I worked for Hewlett Packard for 12 years, so I know what ILO is. And from some of the labs, I think you guys also know what ILO is. ILO is the inside lights out interface for the server that gives me full control of the server if I'm able to connect to it. But Comcast is only leaking the record. Those servers are not accessible from the outside world. Same case with Dell. They're only leaking the address space that they have from the outside to from the inside to the outside world. I cannot actually reach those servers from the public side, but I already have a bunch of information that is very useful if I want to do social engineering. I can call our receptionist. Hey, how are you? I think, and many times the names of the offices are included in the DNS server. Hey, are you having problems accessing file server 01.austin.com? No? We're doing some tests and we're having problems with several accounts. Are you sure you're not having problems? Can you give me your password just to make sure so I can run a test for over here, and you can start going from there. You can start getting kind of the idea of how this info can be useful. In the case of Comcast, I already know they're using HP servers and they have ILO servers. I already know that their management network is in the 172.30 range. So I wrote a tool for parsing all of these data, because having the data is useless if I cannot manipulate it and actually use it and extract value from it. So when I'm looking at the data, I wrote a parser tool that is included with the tool itself. So I can parse XML and CSV. I can actually create a list of IP addresses that can be used by other tools. Let's say feed it into Mmap or other tools if I want to scan. I can actually give it IP ranges that it will filter and get me only those chunks of IP ranges for me to work with. I can filter by DNS record type. I can tell it give me only the A records. I can give it A, quad A, and it will only give me the A and quad A, and can specify what type of record I actually want. I can actually set a regex for names of the server. So I can actually give it a regular expression and give me anything that sounds like HSRP or router, or give me anything that actually says test, or give me anything that actually says beta or alpha. The guys I gained some respect for, when I did a zone walk of them, I started finding a bunch of addresses that said test server. And sadly, I cannot mention some of the names of some of the other records because you'll figure out who they are. And they're known for going after people very hard. But was very, very, very interesting. So whenever I'm not in the camera and being recorded, I'll probably let you know what agency is that and what they're actually putting out there in the internet. I can receive a list of unique names that I can later on feed that into my dictionaries for use for other engagements, and can create my own custom list based on my own experience with other organizations. Here you can see the parsing tool. I use it with Comcast. I give it the range for the ILO cards, and I got all of the ILO cards that I got from the Sunwalk. Here you can see another example of another range that they actually had exposed that was internal. No clue what they're actually running there, but still internal records being leaked to the outside world. And I created also a Metasploit plugin, so you can import that data into Metasploit if you want. What you can do is you can just copy the DNSR_import RB file into your home folder, MSF4 plugin folder there. Then you can just load the plugin, and that will give you actually two commands. One of them is called import DNS recon CSV for CSV files. The other one is import DNS recon_XML for imported XML files. Just in case, make sure that you do gem install Nokogiri. It requires Nokogiri for doing the parsing of the XML records. I learned very fast on my first try that using DOM for parsing large amounts of XML is not a good idea, and then I shifted after I saw all of a sudden Python running with 4 gigs of memory. Each of the commands takes the -f option, so you can actually specify the file to import. And here's a small example of one of my lab systems that is a domain that I call Acme Labs. So I just imported the XML, and there you can actually see it importing the different hosts. You can see that it's also determining the service for that host, and it's adding the service into the service table of Metasploit. And it's reading the SRB records, it's enumerating the MX records and adding those as port 25. It's taking DNS records and adding those as 53 UDP, and if there was a zone transfer, it will add 53 TCP to that list. So we'll do some of the work for you, adding all of that information in there. So we can look at services, and there we can see the services added: finger, HTTP, HTTPS, HTTP, SIP internals. All of those were added, and the ports were already added for these different targets. So that's the end of my presentation. Do any of you have any questions? Or if you work for any of those companies, I'm sorry I used an example. Yes. Did I scan Apple? Yes. But didn't get too much. Any other question? No? Then I thank you guys for coming and listening to me.